our answers now, and then
Sure.
we can defend it since they're exactly the same.
Yeah.
Okay. So, number 1, I got A.
Yes. Did you get that too? I can come through them. Okay. Really quick. With the intermediate quantitative front and constructing a confidence interval satisfied why or not. You on 2 now? I'm in 2. Oh! So, sorry. Researchers, I'm still stuck on 1. Researchers at University of Mississippi wanted to determine whether the reaction time, go, no-go stimulus of male different from females. The researcher randomly selected 20 females with females. The go, no-go stimulus required the student to respond to particular stimulus. Okay, so you're going to use it for 2 things. The researcher decided to construct a confidence interval to determine if the difference of the mean is significant. Determine whether the confidence interval would be reliable to create PQ plot approximately normal. Are the requirement for constructing a confidence interval satisfied? Why or not? I didn't know. What did you guys say?
I put B.
Because we've been determining that be normal. Wait, you said B?
Yeah, B.
That's the distribution of the mean of each sample is normal since they have been determined to be normal. Makes sense.
But, yeah. Because it doesn't really say if they're like really large or really small. And so A and B don't really apply. And then D don't use that.
Yeah.
It doesn't have anything to do with what we're doing, so yeah. Okay.
Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Okay.
A, confidence interval for mean when standard deviation is known. Confidence interval for mean when standard deviation is unknown. Confidence interval for the mean of differences using dependent samples. Confidence interval for the difference of means using independent samples.
I don't know. Okay, how do you know which confident interval to use for which? I don't know.
So it depends on what we're doing. So since there's 2 different samples, they want to look at males and females to see if there's a difference. And so for that, we're going to be using independent because they're not related to each other. It's not like they depend on each other, or it's not before and after. And so it's not dependent because they don't depend on each other.
So
and
like there are other factors that are influencing it,
So
or they're
let's
looking for
say-
something else.
So dependent mean like the income and the difference in income because they're dependent on each other, right? That would be an example of dependent samples.
So dependent sample would be like the price of an airplane ticket, like months before, and then 2 days before. Because it's the same thing, but it changes over time. So that's what like dependent. You're just kind of comparing the difference between those two. But independent is like they're 2 different people, they're 2 different, something like that.
Gotcha. So then for this, it will be independent because it's different, male and female, both 2 different groups, right?
Yep. Yeah.
And they're just trying to find out, do they react to a stimulus or do they not?
Mhm. Yeah.
Okay.
Okay. And then 4, so we're looking researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3402 and 4142, which with the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval. So smaller margin of error, I said obtain balances of 90 bank customers rather than 30.
So then we have more samples. You have a small margin of error. Is that correct?
I think so. That's what I was remembering. Is that what you guys have too?
I didn't know. I just
Okay.
I was like,
Yeah, a lot of these I wasn't totally
I think that sounds about right because
Yeah.
I took statistics in high school.
Yeah.
So that's
Me
been a
too.
really long time. But that sounds
so
like it's correct because the 95% confidence interval, we always had to calculate out our margins of error. And the smaller margin of error usually was same.
Yeah. Okay.
Okay. If a factory makes propeller drive shaft for ships, the quality assurance engineer at the factory needed to estimate the true mean or length of the shaft. They randomly select 4 drive shafts made at factory, measure their length, and find the sample mean to be 1,000 millimeters. The lengths are known to follow normal distribution, whose standard deviation is 2 millimeters. Calculate 95% confidential interval for the true mean of length of shaft. So I didn't know, forgot how to calculate this.
Isn't it not when you just take your 1,000 millimeters and you subtract the 2 millimeters and add 2 millimeters to that in order to...
I think so. I know there's a formula, like if you click on whatever lesson it was, they showed the formula, and I just used that, and I got A.
Okay.
Wait,
So just a second, let me just take a sec to copy this out.
So what was the... constellation?
And you said you got A?
Yeah. It was
Wait,
998.
So what did you do? Can you tell me the formula that you used?
I think it's the... Okay.
Isn't it 68.95?
It's the mean plus or minus the 1.96, which is the 95% confidence interval, and then times the standard deviation divided by the square root of the sample size.
Okay, so then we have, so the sample mean would be 1,000, right?
Yeah.
Plus or minus 1.96, because that's the thing for the 95%.
Yep.
And then the standard deviation which we have is 2 divided by the square root of n. But where is n? How do you figure out n?
They tell you that it's 100 people, I think. Or there's 100 things. Oh no, she randomly selects 4 drive shafts, so it's divided by 4. For the square root.
She randomly selects 4 drive. Oh, so 4 is your...
Yeah.
Oh, okay.
Yep, so that's how I got it.
So that would be equal then.
I got 0.06. Yeah, so I got...
You got 1.001.96 and then 98.04. Okay. Okay, so that makes sense.
Yep.
Basketball, volleyball, league.
So the next one, just to make sure that I have that correct, so it would be
To assess the accuracy of the laboratory scale, the standard weight is a known weight to be 1 gram. Is repeated weight weighted a total of n times. So we're trying to find n. The mean of the weight is computed. Unknown standard deviation is that. So you find n. I think there's an equation too. So you take the 9.6 interval times the standard deviation, which was 0.01, divided by the margin of error, right?
Yeah.
0.0001, and that's all square. So am I making any sense?
all squared.
Times 0.096 times 0.01 divided by 0.001. I got 386. Is that what you got, Eliza?
Yeah. C 38416.
Did you get that? This equation here. Calculating the sample size.
Oh, 2 times.
Mm.
2 times the standard.
No. This is the confidence interval.
Oh, the confidence. Okay,
It's the Z, sorry. Z, whatever.
Oh, Z. I'm like,
Z, yeah.
what's the 2 in there for? Where'd that come from? Okay, yeah.
Calculate what. So it is n equals confidence times the change divided by margin of error, and everything square rooted. Yeah, I have to do that. So I need to remember what I did. Okay, so 7. Are we on 7?
Yeah.
The mean area of the several thousand apartment in a new development is advertised to be 1250 square feet. The tenant group think that the apartment are smaller than advertised. They hire engineer to measure a random sample apartment to test their suspicions. They appropriately. Okay, so we're just trying to find the null. So the null is that it is equal to 1250, and then the alternative is saying that it is either less, like it's
less
smaller,
than-
smaller than what is advertised. So it'd be A.
Yeah. That's what I got.
Okay. B. In a statistical test of a hypothesis, the test result is statistically significant at a level of significance. If I just put A, that's what we normally use, right? Or am I wrong?
Well, I wasn't sure on that one because, okay, we say the data is statistically significant at the level of significance alpha. Because is it at the p-value is less than alpha,
So
or is
let's
it 0.05? Because I was like, well, both are kind of true, and so I'm not totally sure on that one.
we say
And sometimes we use the alpha that's different than 0.05, just not as much.
I guess I don't understand what they're asking in their question.
Yeah.
In a statistical of hypothesis, say the test result is statistically significant at the level of significance if
Alpha is 0.05, but then I don't know if they're asking me, wouldn't, I don't know if they're asking me
yeah,
if you're saying when
it's
you make
larger
it or smaller than
it's
A.
less than.
But when I read this, I thought they're asking where do we normally have our level of significance? Normally at 0.05, but I don't know if they're
Yeah.
asking me if when do you actually make, I don't know.
Yeah, I was just thinking like it's statistically significant when it's less than alpha because then that's when we reject or we fail to reject or if it's less than that, that's when we fail to reject or that's when we reject the null hypothesis.
I know what you're trying to say.
Just
I
confuse
I like the little thing that he said because it helps me remember the less than.
Yeah, me too.
If he is low, then reject the null.
Yeah, that's the only way I remember it.
Because otherwise, I'm like, wait, I failed to reject it. Wait, okay, just let me think. Let me think
Yeah.
about this. Yeah. Okay.
I'll just put P as less than because
So, statistics students want to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample size of 15 from each of 4 different apartment buildings. The data for each apartment building is bell-shaped with no outliers, and the sample standard deviations are nearly equal. And they use an ANOVA hypothesis test to answer their question. Wouldn't it be no, they don't have enough to go off of?
I think so. Well, they have to have a normal.
They have to have the mean, don't they?
Well,
Information in order to figure out if they can do that, or here we go.
So if they take 15 out of 4 apartments,
Yeah.
they will be at 60 samples.
So
And then the data for each apartment are bell-shaped, so that means that they're normally distributed with no outliers, and the sample standard deviation are nearly equal.
yeah.
Can they use, what is it? Oh,
Because those are the only 2 requirements for ANOVA.
yeah. Boy, it won't be B.
yeah.
Yes, they have a total of 60 GPAs and all students apply. No.
And
Yes, it is enough that data are bell-shaped with no outliers and the sample deviation are nearly equal. I think it's A.
I think so too.
Because that's all you need the requirement to do a NOVA. Because they need to be normally distributed and the variance need to be equal.
pretty equal. Yeah. Okay.
Yeah, I think so.
I don't know why I can think like this, but when I take the exam, I can't think like this.
Medical researchers working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. The null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an earlier trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the null hypothesis would be rejected at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has a second. So, if they reject the original no, then that would be a type 1 error, wouldn't it be? Because they reject the original even though the original was true. Or would
Yeah,
it be
that's
type
what I
2?
think it would be type 1.
Okay. Right? They said they changed their null because of the 4.5 years, but later they find out that it's not the new treatment that increases the survival.
Yeah.
So yeah, right? It would be A then, right?
Yeah. Yeah, it would be. Okay, 12. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? And I think it's D. By reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah. Because they talked about in the lesson how if you increase one, you decrease the other, and if you decrease one, you increase the other.
Yeah.
That makes sense.
Okay. That was actually 11, right, Eliza? Look at the numbers here. But
So.
okay. The nicotine content in a cigarette, certain brand, is normally distributed with the mean and in a known standard deviation of 15. The brand advertises that the mean nicotine content of a cigarette is 1.5, but the measurement on the random sample of 100 cigarettes of this brand gives a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised, or is it the hypothesis null equals 1.5 and alternative is greater than 1.5? At 5% level significant, you could conclude that you should. I put down C. There is a 5 chance the null hypothesis is true, right? Because if it's greater than well, I don't know if that's the positive. Well, I guess, I don't know. If the levels of significance is at 5%, then we need to be less than that when we reject it, right? Less than the 5%, then when we reject, that means that we have enough evidence to say, oh no, wait, I'm not sure anymore. I'm confused.
I put reject the null, but I don't remember how I got that. So.
The mean is 1.5.
Yeah, so they're talking about like the level of significant with that 5%.
Okay, so I did 1.53 minus 1.5 divided by the standard deviation over the square root of n. And then I got, well, let's see. I'll do that real quick.
Wait, say that again?
Okay, so I just did.
You took the sample mean, is that right?
Yeah.
Sample
Sample
the
overpopulation.
actual mean. Right, so 1.53 minus 1.5 is the standard deviation.
Mm-hmm. So when you do that, then you get 0.017, which is lower than 0.05. And then, so the P is low, and so you reject HO.
One second, sorry. So you're lower than 5, so then you reject, right?
Yeah.
You reject null.
Yep.
Because you reject the null, you're saying that there's not enough evidence that the mean of the nicotine content is higher than the 1.5. Is that correct?
Yeah, I think so.
Because we're rejecting the null. So we're saying that the null is not 1.5. We were saying that the hypothesis is correct. Okay, so it's totally valid. Ah, this is so. Okay. I guess it's
Dr.
just
Jen.
walking myself through time. Oh my gosh.
Oh my
Okay.
god.
I guess we're on number 13 now.
Okay.
You will like to look at the mean number of hours worked for wages per week by male student and female student. You will like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So it would be independent because it's two separate people and they're not married or anything, so they're not connected in any way.
Right?
Is that Elizabeth?
Sorry, say that again.
So
Basically,
in my head, it looks like that one that we talked about earlier, how they were taking the means from the girls and the guys on this
Yeah.
stimulus. So
Yeah.
it would be independent again because they're not connected in any way.
Right. Yeah. That's what I was thinking too on that one.
Number 14. I guess I can just take that and finish it off. An educator is interested in academic achievement by males and females with similar academic support system. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brothers and sisters pairs when they are next to each other in siblings. Should she use a hypothesis test based on independent or dependent sampling?
Dependent.
Yeah, I put D, dependent sampling, because if you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study. Does that make sense? So if you choose this brother, you have to choose this sister too. So
It makes sense.
They're depending on each other rather than if she just does boys and girls, you know. Does that make any sense?
Well, not only that, they were talking about how it's similar academic support systems as well.
Mm-hmm.
And not only that, but it's also brother and sisters.
Yeah. Because it wouldn't be C. Sister's academic achievement depends on some degree on the brothers. No.
Yeah.
It's two
No.
separate. But they're dependent based on their sibling relation, not on their degree relation.
Yeah. That makes
Okay.
sense.
Okay, so questions 15 through 26, select and carry out the correct inferential procedure for each set of problems. So a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of an ecosystem and help plants to process organic compounds. A researcher would like to construct a 95% confidence interval for the mean dissolved organic carbonic level in the field. Open the data file, dissolved organic carbon. Use this information to answer questions 15 and 16. So, that one's for school, right?
Yeah, but these are dissolved organic carbon.
And we're looking at, of the 4 types of confidence intervals listed below, which is appropriate for the situation? Confidence interval for mean when sigma, or the standard deviation, is a known, unknown. Confidence interval for the mean of differences using dependent samples. The confidence interval for the difference means using independent samples.
I think it's unknown because it's just one category of data and they don't tell us what the population standard deviation is.
Yeah, it's just talking about the carbon levels. It doesn't really put anything else in there.
Yeah,
It's on the,
So
is
it would be
standard-
unknown.
standard
Because-
deviation is unknown.
yeah.
Interval when the standard deviation is unknown.
And then 17, which of the following is, or sorry, the 16, which of the following is the 95% confidence interval for these data? I got D. It's 11 point.
So did you just do that on SPSS?
Yeah. Yeah.
So, okay, which one? So we do comparative mean. We use the one sample mean. Wait, I don't.
Since you're not finding like I don't know if you're finding a T-score. I don't remember, but you can just do like compare means and then explore, and it gives you the not compare means, but it's the analyzed and whatever and descriptive, and then explore, and it gives you the confidence interval.
Did you get
Oh, I see.
11.16833 and 15.21737?
Yep. Yeah,
Okay,
I did.
it's because so because you're not figuring out like the T stuff, you just go straight to just doing like a basic simple.
Yeah, so see how
Okay.
it pulls up like this?
Uh-huh.
And you can
I
go
never.
to
Yeah. Okay.
confidence interval for the mean, and then the lower bound is 11.15
That
or
makes sense.
1683 and
I hope I remember
737. Okay. So did you pick B then? Or wait, oh
No, D.
never mind, sorry.
Yeah,
For
it's
some reason
D.
I'm like, I don't see the actual answer in here.
Yeah.
So a random sample of Hummers for sale in LA and New York were taken from listings at cars.com. We want to know if there is any difference in mean listing prices between Hummers for sale in LA, group 1, and Hummers for sale in New York, group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. Open the data file, used Hummers LA and New York. Use this information to answer question 17, 18. So let's pull that. But the question is, of the four the confidence intervals listed below,
He's gone.
okay, I'm gonna start pulling it up both sides so that hopefully we do here. Let's see.
Oh shoot! What just happened?
I don't know.
Still waiting for him.
So we're gonna do the same thing, aren't we? Like do descriptive statistics and do explore.